Okay, welcome to my second video about combinatorics. Today we'll be having a look at combinations. So where the order does not matter. And first we'll be looking at combinations where we have no repetition. And for this, we'll be hitting the lottery here. So if you don't know how a lottery ticket works, what you do, you have an amount of crosses we have to do. For example, this time, let's say only 3 crosses. Normally they're like about 6. And you cross out one number. Let's say you cross out the 17, then you cross out the 11, and then the 12. Then in the end, they have a big ball, a big machine with lots of balls, where they pull out 3 different balls, like every ball is in there once. And then if they pull out the 11, the 12, or the 17, and which order does not matter, you win the lottery and you win lots of money. So let's look at how many solutions there actually are for pulling out crossing out 3 different numbers on a 94 number board. So if you think about it, it's kind of similar to our permutations where we have no repetition. If you remember this tree from last time, what we had here is first we can cross out 49 different numbers, then we can cross out 48 different numbers, and then we can cross out 47 different numbers. And this was then just n factorial over n minus r factorial. So we have the same here. The only difference is we can first, for example, we can first cross out this 11, then the 12, then the 17. But we can also first cross out the 17, then the 11, and then the 12. And in the end, we have the same crosses. So now we look at how many different ways we have to cross out the same 3 numbers. And you can see first we can cross out any of these 3 numbers, any of the 17, the 11, or the 12, and then we can, let me erase something. So first, for example, we can first cross out the 17, and then we have 2 more left, so then we can cross out the 12 or the 11. So let's cross out the 12, and then we can cross out the 11. So first we have 3 different numbers we can cross out, then 2, and then 1, which is just 3 factorial, or in this way, because r is the number of crosses we have to do, it's just r factorial in the denominator. So this is really common use and really commonly used, especially in stochastics, and this is why there's an other way to write this down. This is just n choose r is called, and you just put them over each other in brackets. So this is the same. This is just a different way to write it down, but in the end it's the same. And this will be the solution for our combinations where order does where we have no repetition. So order does not matter and we have no repetition. And I want you to understand why we have a smaller number than with the permutation where order where we have no repetition, where order does matter though. Because if you have a set, let's say 1, okay, I can't really write here. Why can't I? Maybe let's, okay, I can't really write down on this board here. But let's say we have the group of 1, 2, and 3, and this is like one set we have. Then we can just swap out the 1 and the 2, and we have a different set for when we look at the order, but we don't have a different set if we don't look at the order. So there's the same 3 numbers in here and here. So this is why, but in a different order. And this is why this number, like there are less ways to order an amount of numbers from a big pool when we don't look at the order than when we look at the order, because we can just swap out like the first and the second place or the first and the third place, and we have a whole different combination for when we look at the order. But if you don't look at the order, the set stays the same. So now we come to the most complicated one, and one which I will use a only blank and I will write down, and because it's really complicated and I don't expect you to understand everything, but what we have here is now we look at sets where the order that we have does not matter, and we can have the same number multiple times. So for example, let's use the numbers 1, 2, okay, let's say terrible 2 and 3. Let me do the 2 again. A little bit better. And for example, we can have first, oh my god, I'm really terrible at this, sorry. We can have first, we can have a 1, a 1, a 3, and a 1. And because we don't look at the order, this is actually the same as just having a 3 followed by 3 1s. So these two sets are the same because they each have 3 1s and 1 3, and the order in which they appear, it doesn't matter. But this would be a different set than, for example, having a 2, a 1, a 1, and a 3. This will be different because now we don't have our 3 1s and our 2 anymore, and our 1 3 anymore, but we have a 2 instead of 1 1. So now what we do is we have so 1 2 3, these are our n numbers, and we pull out 4, which is our r amount, and now we no wait, other way around. Sorry. We have 1 2 3 is our r amount, and we pull out it's our n amount, and we pull out r of, oh wait, I'm so bad. We have r 1 2 3, and we pull out n amount of numbers out of them. So we can look at this as having n amount of stars. So we have 4 stars. And now we feature our lines. We have n minus 1 amount of lines, so we have 3 lines. No, we have r minus 1. We have r minus 1 of lines, so we have 2 lines. And we can now put into any position where we want. So we can, for example, put in a bracket here, and we can put one bracket here. And now you see we kind of divided it in two different parts. Or let's say for beginners, we put one bracket here and one bracket here. Now you can see the 3 different parts that we actually created, because we created 3 different parts for our 3 different numbers. So the first part is the 1, then the second part is the 2, and the third part is the 3. And this just shows how many of the stars just show how many times each number is represented. So for example, this combination of stars and lines features all sets that have two ones, 1, 2, and 1, 3. For example, this one here. We have 2 1s, 1, 2, and 1, 3. What it also would represent this one right here, where we have 3, 1, 2, and 1, which is a different method of just, again, writing down the same set, but it's all is featured in this one set. So we don't have to write down every single set. We have them all featured by these combination of stars and lines. And if we now want to represent our first 2 sets here, what we can do is we can do what I did earlier. And now we separate them again in 3 different sets, only that here the 3 is empty. So we, oh wait, no, we do it like this because we have no 2. So we do it like this. So we have no 2 and we have 1, 3. And this will actually be these 2 different sets. Then if we then would do this here, for example, now, then we would have 3 1s and 1 2 and no 0. So for example, we would have the set of 2 1 1 1. So now the every element of this now is determined by where we put our lines. So it's completely determined by n positions within a set of n plus r minus 1. So we would have n plus r minus 1 over r. No, wait, not over r. Choose r, of course. Which, if you do the math behind this, it's the same as n plus r minus 1 over r factorial n minus 1 factorial. Because in here there would be n plus r minus 1 minus r, and the r just cancels each other out. And this is how we get to this formula here. So what I want you to understand from this is I don't really understand want to understand you to jump from this to this, because once you wrap your head around it, it kind of makes sense. But it's just really hard to understand the first step, or like the step why this is now n plus r minus 1 over choose r. What I want you to understand is the way we can represent each set by making stars and lines. This is what I want you to take away from this. So you know that by putting in n stars and r minus 1 lines, you can represent any set that you can think of, that you can write down with the same parameters by just dividing the stars into 3 different groups by putting in the 2 lines. And then I just want you to remember that this is then how we write it down, or just this here, n plus 1 minus n plus r minus 1 over r. I choose r. Sorry, I always want to say over, but choose r. N plus r minus 1 choose r to calculate any combinations where we have repetition. So thank you for listening. This was my 2 videos about combinatorics. And yeah, please please subscribe to this channel, and I will see you in the next video. Bye bye.